Hi, welcome to the first part of the solution. So here we'll discuss about the data preprocessing part and the necessary analysis to be done on this problem. So first, let's import the datasets and the necessary libraries. So importing, if you want, you may follow me or you may see. Okay, so let's import the dataset. You may get the dataset from the link itself of the hackathon, or I will share the source code and the datasets link into my GitHub URL below to the description. You can download the dataset from there itself. So let's import the dataset. Train df equals to pt dot read csv. So we have imported. Now let's delve into the train data. So here you see we need to predict the severity column. Okay, so we have independent features like safety score, test, since inspection, total safety components, control metric, turbulence in g-force, cabin temperature, accident type code, max elevations, violations, adverse weather matrix, and accident ID. So as you can see in the severity, these are categorical features. Okay, minor damage and injuries, significant damage and fatality, significant damage and serious injuries. So as you can see, there are several classes in the severity column. So it is a multi-class based classification problem. Okay, you need to find out first what type of problem it is, then the solution. You need to approach to the solution. So it is a multi-class based problem. Let's see the data. Okay. So as you can see, there are 10,000 total data in train, where the mean is 41, standard deviation 16. You know, these are the some statistical description of the whole train data. Now let's find out how many classes are there in the severity column. Okay, so group equals to train df dot group. Oh, sorry, it will be severity. Okay, so as you can see, there are total 4 classes: highly fatal and damaging, minor damage and injuries, significant damage and fatalities, which is a class count of 1695, significant damage and serious injuries, class count of 2729. Okay, now as you can see, there are total 4 classes. Okay, so let's find out the unique class names. So yeah, total 4. Okay, so I need to talk about here what is univariate analysis. Like, see, severity is a categorical variable, so we need to find out the frequency of each of the class. So univariate analysis means we get a value from 0 to 1 which depicts the frequency of each of the class. Okay, like train df severity dot value counts normalize equals to true. So you can see 0.30% of highly fatal, 0.27 of significant damage and injuries, 0.25 of minor damage, and 0.16 of significant damage and utilities. Okay, let's see a bar plot visualization of the class. Okay, sorry, I haven't included the matplot library. Let's import it here. Import. Okay, so there is a bar plot visualization of the class. Now let's see if there are any null values in the dataset or not. Yeah. Okay, sorry. So here you can see there are no missing values in the dataset. In each and every column there are 0 missing values. Okay. So let's find out for each type of accident code how many highly fatal values are there, how many minor damages, injuries, significant and damage and fatalities, and significant damage and serious injuries. We need to analyze it with respect to the accident type code. So there is a function in the pandas library called Crosstab. Okay, let's see how it works. You can analyze your data with respect to any of the type. I am showing how you can do it accident type code. Yeah, so here you can see for accident type code 1 there are total highly fatal and damaging 521 values, minor damage 231, 261 values of significant damage and fatality, significant damage and serious injuries 158. So what is the meaning of seeing all these things? The first thing you need to take in your mind that there are some class imbalance. There may be some class imbalance in the dataset. As you can see, there is no class imbalance in the dataset. But sometimes what it happens, there are 3000 values of suppose highly fatal and damaging, and there are only 3 values or 4 values of significant damage and serious injuries. These types are called, they are imbalanced classes. So we need to smooth, means synthetically, we need to create some data that are synthetic data. Okay, we'll talk about it later. So let's find out the importance of all the features of the dataset. Okay, importance of the features. So we will use ensemble learning to show the features of the each. So for calculating the features importance, we will use ensemble trees for our purpose. So let's import from sklearn. So what is extra tree classifier? Here you can see that extra tree classifier is nothing but a random forest implementation. It generates a decision tree and computes each and every feature's importance. Okay, you need to call the object of it extra trees classifier. Then you need to fit your model onto it. But before fitting your model, okay, we need to define what our x and y is. Okay, so first we define our x and y. So x equals to our train df severity. Sorry, this is our predictive feature, means y severity, and our x equals to train df dot drop severity. X is equals to 1. The model dot fit x comma y. Okay, yeah, the model has been fit. These are the inbuilt parameters of extra tree classifiers. These are default values of each of the parameters. You may change it also if you want. It depends upon several techniques and several parameters you want to try. Okay, so let's find out the feature importances. Model dot sort the feature importance with in descending order and to plot it. Okay, here we made a mistake. Okay, so as you can see, safety score, DSIS inspection, control metric, accident type code. These are the descending order features importance. So safety score had the highest feature importance, then DSIS inspection, control metric, accident type code. So To solve this problem, I have used firstly I have used the first 5 of the features, because we all know that dimension is a great issue. So to reduce the dimensionality and also to retain the threshold, we have used only 4 of the top features like safety score, test inspection, control metric, and accident type code. As you can see, the amount is 0.125, near about 0.125. So I keep a threshold of 0.125 and used all the features that have greater value than it. Okay. So let's see the distribution of safety score. Relevant features. Oh, sorry, can't. Let's iterate over the relevant features. Model C1 has no attribute. Count for. Okay. 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 Let's remove it. We'll see it later. So as you can see, these are the feature importance. The most relevant one are this. So if you want to get better results, you need to first try about taking top 6 or 5 features and to build a model, and also uh, removing one feature at a time. That is called sometimes backward elimination. So by backward eliminations, you remove one feature, put into the model and see the accuracy. And in my case, I got this first 2 feature. So first priority, second priority, third priority, and fourth priority. Okay. So fourth priority, and this is third priority. So in order to build this model, I will use safety score, test and control metric, and accident type code. Okay. The model building part I will show you in the next part. If you have any doubt on this section, please know me in the comment section. And if you want more detailed analysis of the data preprocessing part, please know me in the comment section. I will look into it. Thank you.